I welcome you all to the session of engine system and performance, and in today's class we shall discuss about the classification of engines, and then we shall briefly touch upon the nomenclature of engine. I mean to understand different parts of an engine. So, what I would like to discuss today is the classification. Probably you have studied this part in your undergraduate internal combustion engine course. So, you know that engines are classified into several categories. Broadly, internal combustion engines can be classified into two categories, but these two categories are not only the classification of engine, but there are many other categories that we will discuss today. So, if we just write engine classification. As I said that engines can be classified broadly into two categories. Let us revisit those two categories first. The first category is based on the number of stroke. And based on this point, we can classify engine into two categories. One is 4-stroke engine and another category is or subcategory is 2-stroke engine. Though 2-stroke engines are now almost obsolete. So, what is a 4-stroke engine? 4-stroke engine, as I said you that you have studied this topic in your undergraduate internal combustion engine course. In a 4-stroke engine, two rotation of the crank per cycle, whereas in a 2-stroke engine only one rotation of the crank per cycle. I am not going to discuss in detail about what is crank rotation. Probably there are four in a 4-stroke engine we could classify 4 distinct strokes like intake, then compression, then third is the power stroke and finally exhaust. So, as I said you in a 4-stroke engine, what are the 4 different strokes? Intake, then compression, then finally power stroke, and certainly the combustion gases, combustion products should be expelled out from the combustion chamber. So, there must be the last stroke, that is the exhaust stroke. In a 2-stroke engine, the first 3 strokes are combined together and exhaust stroke will be there. So, in a 2-stroke engine, intake, exhaust, compression and power, all these strokes will be there, but out of these 4 strokes, 3 different strokes should be combined together. I mean in one stroke, in one go, these 3 events will occur and finally power stroke will be there. So, that part I am not going to discuss here in detail. Second is that is very important, that is types of combustion. Based on this point, again engine can be classified into two categories, subcategories. One is SI engine and the last one is compression ignition or CI engine. So, this SI is spark ignition and this is compression ignition. So, this is based on the type of or types of combustion. In a spark ignition engine, you know that the fuel or air fuel mixture, which is also known as charge, the charge cannot combust automatically and there is a necessity of an external agent which is the spark plug, and that spark plug helps to ignite the charge and thereafter entire combustion will take place. On the other hand, in a compression ignition engine, there is no need of an external agent like spark plug. Instead, the thermodynamic state of the compressed air at the end of the compression stroke helps the fuel to ignite the moment when fuel is sprayed into the combustion chamber. So, this is basically the second type of classification. Probably you have studied these two in your undergraduate course, but not only these two are the broad classification. So, if I write here, these two are the broad classification. Next, let us discuss about another types. So, that I am writing third type, that is valve location. Very quickly I shall try to complete this because these are not very important, but just to recapitulate in the context of this subject I am discussing valve location. So, again it can be right, this is called overhead valve, right, this is also known as I head engine, then it is valve in block. So, overhead valve in, the valve is in the top, then this is called valves in blocks, this is called T head engine, C is one in head. So, overhead engines, so valves in head and one in head, and typically one in head means intake and one in block. This is called F head engine, but this particular type is not very common, while the first two are very common, while the last the last is not, this is less common. While the first two are very common, the last one is less common. So, this classification is based on the valve location. What next? Then is basic design. So, as in this course we shall mostly discuss about engine system, engine structure, several components, several control systems. So, this type is very important, that is basic design. So, this classification based on this point we also can classify engine like you have like reciprocating type and another type is rotary type. So, this classification is based on the basic design. Reciprocating engine you have studied that the piston needs to travel between these two locations, piston needs to reciprocate between these two locations, that is top dead center or inner dead center or the bottom dead center or the outer dead center. While the rotary type you know that there is a special arrangement, in fact we shall be discussing about this particular type when we shall be discussing about the discuss about the engine structure. Okay. So, this is basic type. Then if we go to the next one, that is position and number of cylinders. In reciprocating engine. So, knowing that engine can be classified into two categories based on their basic design, that is reciprocating type and rotary type, and in reciprocating type piston reciprocates between these two locations and those locations are bottom dead center and top dead center or outer dead center or inner dead center. Again the reciprocating engine can be further classified depending on the position and number of cylinders. So, if we again look at this particular type, then we can have V engine, V shaped, then opposed cylinder type, radial engine, and opposed piston type. Okay. So, you can understand these sub classifications are basically depending on the arrangement of the cylinder, piston, etc. And this particular classification is applicable for a reciprocating type engine. Then 6 is air intake process. This particular type is not applicable to any specific type of engine. So, air intake process, again if we look at several sub classifications, then we can write or we can classify into several sub categories. The first one is naturally aspirated. What does it mean? That means to suck air into the engine cylinder or air to be drawn into the engine cylinder, there is no need of air intake boost up system. So, just I am writing no air intake pressure boost system. See, you have studied that when there is an intake stroke, piston comes down from the top dead center into the bottom dead center, and that movement of the piston from TDC to BDC or inner dead center to the outer dead center automatically allows air to be drawn into the cylinder. There is no need of any air intake pressure boost system. So, this is naturally aspirated. Then what is second type is supercharged. Supercharged means just because of the movement of piston from TDC to BDC is not sufficient to get required amount of air for the combustion. We need to have a special device, that is a small compressor, and that compressor will boost up or pressurize air to go into the combustion chamber. So, this is supercharged. There is also another subtype that is called turbocharged. So, basically you know that you have studied in your undergraduate IC engine course that the exhaust gas or exhaust gases come out from the engine or combustion chamber. Instead of directly discharging those combustion gases into the ambience, we can take those gases to run a small turbine, to propel a turbine, and the turbine will give some amount of power, and while the turbine is moving we also can connect another small compressor to that common shaft of the turbine, and that small compressor will now allow air to be drawn into the engine cylinder with relatively higher pressure, and that is the turbocharge. And finally, this is also not very common, that crankcase compressed. So, I hope you have understood that essentially when you need to have air intake pressure boost up system, that means we need to increase the pressure of the intake incoming air. Whether we are increasing pressure by having only supercharged system or by having coupled turbine compressor, that is turbocharged system, that depends on the requirement, but we also can have we also can pressurize air or intake air using crankcase compressed system. So, this is the sixth type. We can go to the next one, that is based on the method of fuel input. That is again not applicable for SI engine or SI engines, this is for compression ignition engine, right. So, we can have direct injection, in this case fuel is supplied directly to the combustion chamber. And subtype B is indirect injection. In this case, certainly you can understand, instead of supplying fuel directly to the combustion chamber, fuel is supplied to the secondary chamber first. So, this is indirect type. So, again I am telling this type is applicable for this CI engine, compression ignition engines, because we all know by this time that in a spark ignition engine fuel is supplied into the engine cylinder by through the carburetor, a special device wherein fuel is allowed to mix with the incoming air. Then next type is based on the method of fuel input. As such, I should have discussed this particular type before discussing the previous one, that is method of fuel input for CI engine. Method of fuel input, it can be through carburation, that is carbureted. As I said you that in SI engines fuel is mixed with the fresh air in a special device that is called carburetor, and that fuel air mixture is supplied into the combustion chamber. So, this is basically called carburation system or carbureted fuel input. B is this is called MPFI, that is very important, and in most of the modern engines this system is equipped with, that is multi-port fuel injection. To bring the economy of the fuel economy, rather to increase the overall efficiency of the engine or combustion efficiency, instead of supplying fuel through only one port, we can supply fuel through multiple ports. So, this is the modern engine modification, rather I should say modern engine system. So, multiple port fuel injection. C is throttle body injection. Throttle body injection is injection of fuel in the fuel is injected upstream in the intake manifold. So, injection upstream in intake manifold. So, this is called throttle body injection, and D is gasoline direct injection. That is again mostly for the CI engines, and what we have discussed just before, that is method of fuel input for CI engines. Now, when you are supplying gasoline, that can be supplied directly into the combustion chamber or it can be supplied to the secondary chamber. So, that classification already you have discussed. Okay. Then next type is fuel used. This is very common. So, it can be gasoline type. So, we can use gasoline as a fuel, we can use diesel, we can use gas, we can use LPG, we can use alcohol, ethanol, and we also can use dual fuel. So, dual fuel is very common nowadays, that in most of the engines nowadays a provision is there that we can run engine for a long time using either alcohol or LPG, but we need to start the engine using either diesel oil or any other fuel oil. So, this is basically classification is based on the type of fuel used, and the last one that I used to discuss, which is very common, that is types of cooling. So, this is very important because you can now recall that in the last two classes we have discussed that cooling system is an important system for the engine. Now, the cooling can be using air as a coolant, or the engine can be cooled again using water. So, depending on whether we are using air or water as a coolant, we can name engines either air cooled engines or water cooled engines. So, these types of coolant, it can be either air cooled engine or water cooled engine. So, all these are basically several classifications of internal combustion engines. Though there are two broad classifications that we have discussed today, that is the first one is number of stroke and second one is types of combustion. But still there are many other classification, probably you have not studied in your undergraduate course, and also as I said, just to recapitulate, we have discussed all these types today, and now we shall discuss about the engine nomenclature. Engine nomenclature, just to know about several components, several parts which are responsible to operate an engine efficiently and smoothly. We have seen this schematic depiction in our previous two classes, but today we shall discuss this in a little more elaborative way. So, what we can see that this is the schematic depiction of a spark ignition engine, because you can see the spark plug is there. If we remove this spark plug and if we just place one fuel injector over here, then the engine can be a compression ignition type engine. So, if we replace this spark plug by a fuel injector or fuel nozzle, then we can call it as compression ignition engine. I mean, all other components will be the same. Okay. So, you can see that this carburetor is a device that we have placed over here, and this carburetor is important and essential element for the spark ignition engine, wherein fuel and air, these two streams are coming and they are mixing together. The function of this carburetor is to supply stoichiometric air fuel ratio to the engine depending upon the requirement. Then we have a throttle valve, because throttle valve is used to supply air fuel mixture, just to monitor the quantity of air fuel mixture to be supplied into the engine cylinder. Then we have intake manifold and intake valve. So, this is very old system, wherein the valve opening and closing is controlled by a cam and follower mechanism, right. So, a spring loaded valve, since it is spring loaded valve, the tendency of the valve will be always closed. So, by tuning this cam follower system, we can open the valve depending upon the requirement. Then as I said you know that we have the spark plug, which is again an important element for the spark ignition engine, because the air fuel mixture, which is also known as charge, to be drawn into the engine cylinder during intake stroke will not be able to combust automatically until and unless we initiate a spark using this element, that is spark plug. So, we shall discuss about the spark plug circuit and how we can get a spark in detail in our subsequent lectures. Then this exhaust manifold is there because through which the combustion gases, after the combustion process, all combustion gases will leave through this manifold, that is exhaust manifold, into the ambience. As I discussed today, that instead of directly discharging all these combustion gases into the ambience, we can take that high pressure, high temperature gases to run a small turbine, to rotate a small turbine, and the turbine will be, you also can connect a small compression to the common shaft of the turbine, so that we also can run a compressor. The compressor can compress the air, that intake air. So, this is called turbocharged, and then you can see that there are two locations, that is top dead center and bottom dead center. So, top dead center and bottom dead center, these two centers are basically very important, and the piston travels between these two locations, and the distance between these two centers is known as stroke length. So, the piston can travel between these two locations. You can see this is the piston, and there is an essential element, that is water cooling jacket. So, it is water cooling jacket because that water is supplied through this jacket just to reduce the temperature of the cylinder wall. As I said you in one of the previous classes, that temperature that will produce or that will develop due to the combustion, that temperature, if we do not allow that temperature to reduce, then there will be several other problematic issues. Thermal crack might generate, and that may lead to damage of the engine cylinder, also the piston. So, though the it is very confusing, because the objective is to have efficient combustion, the objective is to have energy which is remaining stored in the fuel, that energy should be converted into heat energy, and that heat energy is converted eventually into the another form of energy, that is in the form of work, through this crank and connecting rod mechanism. So, this is that this is connecting rod and this is crank. So, that energy, that heat will be converted into work. So, now the question is, it is not possible to convert entire heat into equivalent amount of work. So, we must take away certain amount of heat through this supply of coolant, and that is why this cooling water jacket is important. And you can see piston rings are provided. So, piston rings basically act like the sealing so that combustion gases cannot leak out through this through the gap between piston and piston outer wall and cylinder inner wall. And also because piston is continuously reciprocating between these two locations, the friction between these two mating components can also reduce the lifetime of the piston. But now since piston rings are provided with, so piston rings can be replaced, but the piston lifetime can be increased. And this connecting rod and crank mechanism is there just to convert the reciprocating motion of this piston into the rotary one, so that we can get some useful amount of work at the shaft. And this oil pan is there, that we also have discussed about the lubrication system in one of the previous classes. So, this oil pan, this crank, by virtue of churning action, that supplies or spray oil, lubricating oil into the wall of the or inner wall of the cylinder, so that it can reduce the friction between piston ring and the cylinder inner wall. So, basically just I have tried to briefly describe parts or major components of an engine, and all parts will be there even in a compression ignition engine, but only the spark plug should be replaced by a fuel nozzle or fuel injection system. So, to summarize today's class, we have discussed about engine classifications, and then we have discussed about several components or important or essential elements of both SI and CI engines. With this I stop here today, and in the next class we shall discuss about the basic cycles, and we shall try to mathematically describe the thermal efficiencies of both CI and SI engines. Thank you.